right, so today we're going to get into some of the actual meat of the class material, starting with some basic concepts, warming of the Earth and its atmosphere. So we'll discuss things like heat transfer, what are the methods of heat transfer, the heat budget, or sometimes called the energy budget, the greenhouse effect, albedo, and seasons. Why do we have them and when do they occur? So we're going to start with heat or energy transfer, and hopefully this is review some very basic information, but it's good to have a reminder anyways. So conduction is the transfer of energy through molecular activity. So you see the guy holding the fire poker there, and the heat is traveling through the molecules in the metal poker up to his hand. So that's why he's wearing a glove. So that's conduction. Convection is the transfer of energy due to differences in temperature. And so basically here, hot materials, and we'll use air since we'll be talking about the atmosphere, become less dense and rise. Whereas if the air cools, it becomes more dense and it sinks. And so you can see the rising and falling, that causes the movement of energy. And then radiation is the transfer of energy that does not require a medium. And a medium simply means a material to transfer through or move through. And it's very fortunate that this exists because this is how we receive the energy from the sun here on Earth. And so this is a good example. You see the guy kind of holding his hands back from the fire. He feels the heat coming off from that fire, though he's not making contact with it. We'll talk about the changes of states of matter. I'm assuming you've probably heard or seen of all of these. So freezing, of course, is becoming a solid. Most people associate that with the freezing temperature of water, but that doesn't have to be water. So there's no temperature associated with freezing per se, right? So anytime anything becomes a solid, like a rock, when it becomes solid, freezes, right? Melting, of course, is then changing from a solid to a liquid. Evaporation is liquid to gas. Condensation is gas to liquid. The two you may not be as familiar with are sublimation and deposition. So sublimation is a solid directly to a gas. It skips the liquid phase. And the best example I can give you of this is dry ice. And then deposition is the reverse of sublimation. And deposition is a gas directly to a solid, skipping the liquid phase. An example of that I can give you is frost on your windshield. It takes the water vapor, which is a gas in the atmosphere, and it skips the liquid phase and deposits as a solid ice crystal on your windshield. So latent heat, I hate the word heat because it implies temperature. It's more energy. So it is the amount of energy either absorbed or released during a change of phase. So that is at a constant temperature and pressure. And so you can kind of see in some diagrams that energy is being released or absorbed, okay? Temperature versus heat, they are two different things. Temperature is defined as the average speed of molecules or atoms and molecules, whereas heat is the energy in the process of being transferred from one object to another because of differences in temperature. And so what I have here for you are some common temperature units, right? We're familiar with degrees Fahrenheit. If I told you it's 70 degrees outside, you would automatically assume Fahrenheit, and you would have an idea of what that feels like. The rest of the world being on the metric system is using Celsius, the column there in the middle. And then, of course, there's also degrees Kelvin. And so you will see, you can kind of, this is a neat diagram here because you can see kind of how those relate to each other side by side there. So we're going to talk about the electromagnetic spectrum briefly, which I'm hoping is a review for most or all of you. Basically because we're going to be talking about the energy budget and solar radiation being shortwave radiation. And so we need to have an idea of what that means. So hopefully most of us know that the sun's energy is in the form of ultraviolet. And you can see that right here. It is on the shorter end of the electromagnetic spectrum. So we would consider that shortwave radiation. And of course, UC, conveniently named, in the visible spectrum. And then flowing through the room right now are these long wave radio waves, completely harmless to you. You don't detect or notice them. Obviously, if we get down in this end of the spectrum to the very short wavelengths, we start having concerns with, long-term exposure, we know can possibly lead to cancer. So again, hoping this is a review for you. So let's talk about Earth's energy budget. So we have the incoming solar radiation in the form of shortwave radiation, and we said that was ultraviolet. That energy doesn't just come in and bounce right back out into space. So several things can happen. The energy can be scattered, reflected, absorbed, or re-emitted. And so the one maybe we're not as familiar with is the term scattering, which is the process of a wave, in the case of light, being diffused or deflected by collisions with particles of the medium. Again, a medium is just an object that it's going through, in this case, the atmosphere, that it traverses. So only about 50% of incoming solar radiation actually reaches the Earth's surface. Other things happen to it on its way in. So maybe you have wondered this, thought about this question before. I know I always did before I taught meteorology. Why does the sky in general appear blue during the daytime? Or why are sunsets red? Why do clouds appear white? And those are all good questions. And it has to do with what we call selective scattering of incoming solar radiation. So if you look up at the light bulb in the room that you're sitting in, you're seeing things in white, right? You don't see any colors of the rainbow. You see white light. Whereas if you would hold a prism up to that light, it would bend the light such that you could see the rainbow, right? The red, orange, yellow, green, blue, indigo, and violet. And so basically, what we perceive as color is actually the bending of light in the atmosphere. So it's basically that part of the spectrum that we're seeing. And so in the case of an average day coming through the atmosphere, we see blue. As the sun comes in at a slightly different angle at sunset, we start seeing colors like reds and oranges and pinks. So here's the energy budget of Earth. Thank you, NASA, for this image. But again, you can take a moment to look at this. I'm not expecting you to memorize this whole chart. What I want you to appreciate, again, is that the energy doesn't just come in and bounce right out, right? So the energy can be scattered, as we discussed. It can be absorbed by Earth and re-emitted in long-wave radiation in the form of infrared. It can be reflected off of things like clouds or glaciers or water. So there's lots of things that's happening with this energy. It's not just coming in and bouncing right back out into space. Some of it is, but a large portion of it is being either absorbed or scattered or re-emitted. So let's talk briefly about the greenhouse effect. This has kind of become a buzz term that has a negative connotation to it. But basically, it's atmospheric heating caused by shortwave solar radiation. And particular gases kind of act as a blanket trapping some of that energy. And some of those atmospheric gases include carbon dioxide, water vapor, and methane are big ones. It's the rise in CO2 or carbon dioxide levels that people are really concerned with. But the greenhouse effect is not necessarily a bad thing. It's when it becomes out of balance that we start having a concern. So again, here are some of your major greenhouse gases and some of the things at least humans do. Keep in mind there's natural processes that also produce some of these that contribute to the greenhouse effect, right? Carbon dioxide, burning of fossil fuels, methane is produced in agriculture and the burning of natural gas. Landfills, believe it or not, produce a lot of methane in the decay process, nitrous oxide, and hydrofluorocarbons. Then albedo is the degree of reflectivity. So if you have a high albedo, a lot of light is being reflected, and things like snow and ice have high albedo. And then seasons are the result of having an axial tilt of 23.5 degrees. And then these are some dates you will want to remember.